Hello, and welcome back to the Magnavox Odyssey on yet another retro channel. Well, we're going to pick up right where we left off. So if you haven't seen the first video, there'll be a link to it in the corner that you can go and watch it. And what we did in the first video is we disassembled the machine, we cleaned it up some, and we gave it an inspection. We have more cleaning to do, and we'll go ahead and get into that. And we're also going to, in this episode, be replacing the electrolytic capacitors. There are 12 electrolytics on the main board and 2 on one of the daughter cards that'll be being replaced. But the last time I recapped something, things went a little bit pear-shaped. Whoa! Before we get into that potential nightmare, we're going to do a little more cleaning. What we're going to do is, if you recall, we noticed some green crusties on the legs of some of the transistors on the daughter boards. So we're going to try to get some of that taken care of. And what we're going to do is we're going to start with vinegar. And this is just food grade 5% acetic acid vinegar. And I'm going to apply that to the boards, and I'm going to let it sit for a while and hopefully soak in and loosen up some of those green crusties. So all of these boards that have those green crusties will be getting the vinegar applied. Going to make the room stink, but it's a necessary evil. While those soak, we're going to go ahead and start looking at replacing the capacitors on the main board. Now, electrolytic capacitors, as you know, are polar, meaning they have to go in a particular orientation to make sure that their positive lead is connected to the positive, negative lead is connected to the negative. And if you don't do that, you get something like that little explosion that you saw earlier. So I have gone through the board and verified that there are polarity markings. Now, they're on the bottom of the board. So for instance, this capacitor right here, we flip it over, you can see that there is a negative marked on one of the leads for that capacitor, and that's where the negative lead goes. So all of them are marked, and I have gone through all 12 of them on this board and verified that yes, in fact, those capacitors are in the same way that the markings on the board show. So I shouldn't need to do anything but match up the new capacitors with the markings in the silk screen on the back of the board. I ordered a capacitor kit for this from Console 5. They're a pretty reliable place to get capacitors. And you'll see that C15 here, this capacitor, is a 470 microfarad 16 volt. The replacement in the kit for that is a 470 microfarad 16 volt, and it's just much smaller. Capacitors these days are much smaller than they used to be, and these are Rubicon capacitors, so very high quality capacitors that are going to be going in here. Since watching someone replace through-hole capacitors is so very engrossing, I'll just go ahead and continue with the story of the Odyssey. We'll leave that guy on the screen to get on with what he's doing. First, let's go back a little further in time. I mentioned that Ralph Baer is considered the father of video games and that the Odyssey was the first commercial home console, but there are some other firsts that actually factor into this story. The first actual video game is widely accepted to have been developed at the Massachusetts Institute of Technology in 1962 by Steve Russell and others on a DEC PDP-1 with a Type 30 display. It was called Space War! Critically, the code for Space War! Was public domain and was widely distributed to other institutions with PDP-1 minicomputers, including the University of Utah. It was at the University of Utah that Space War! I'm already tired of saying that. That Space War was noticed by a student who had a background working at an amusement arcade managing the games. He thought if you just slapped a coin box on the side of Space War, you'd have a popular attraction that would make money. This was Nolan Bushnell. Yes, that Nolan Bushnell. Bushnell partnered up with video engineer Ted Dabney. They developed the hardware for a game inspired by Space War called Computer Space and ran their first location test in 1971 in a bar frequented by Stanford University students. This was the first coin-operated video game. I'm coming to Magnavox, I promise. Computer Space was a moderate success, but Bushnell felt it was too difficult for any drunk in a bar to play. He needed something simpler. It was also around this time that Bushnell and Dabney rebranded their fledgling company from Syzygy Electronics to Atari. Bushnell attended a demonstration of the Magnavox Odyssey. He found the console lacking, being black and white, having no sound and no ability to keep score, but he did see potential. He went back to Atari and tasked Al Alcorn with making a table tennis type game with 2 paddles, a ball, a running score, and the sound of a cheering crowd for the winner, all again simply inspired by the Odyssey. Needing a name for the new game, this time short and simple won out. Pong was born. They did another location test in a different bar, and when shortly thereafter they were contacted by the bar complaining that the machine wasn't working, they discovered it was because the coin box was absolutely full. They had a hit on their hands. Atari built and sold thousands of Pong cabinets and were soon copied themselves by competitors wanting in on the lucrative new market. At the time, Atari themselves weren't big on enforcing copyright, but they soon found out that Magnavox were. Magnavox sued cash-strapped Atari for copyright infringement. Needing an influx of cash, they developed a home console version of Pong and approached Sears to market and sell it. Sears bit and placed an order for twice as many consoles as Atari said they could make. They had to expand again. They settled the copyright infringement lawsuit with Magnavox for $500,000 and secured a commitment from Magnavox that they'd pursue copyright claims against Atari's competitors who'd cloned the game. 5 years after the Magnavox Odyssey first showed up in a typical American home, Atari launched the Atari Video Computer System, or 2600 as we know it today. And that's the story of how the idea that Ralph Baer had in 1951 led to the success of arguably the most iconic company in video game history. Well, it looks like our friend on the screen there is about done. I'll let him take over now. Okay. That completes the recapping of the main board. I did miscount. There are 13 of those, not 12. I was very careful to double and triple check the polarity. Knowing me, I still probably got it wrong. But that is that done. Our daughter cards have probably been soaking long enough. We will need to come back because we do have 2 electrolytics to change on this daughter board, but we'll get those cleaned off first. I'm going to use IPA and some brushes. To give these boards a quick scrub after the vinegar treatment. Hopefully we will get off any of the green crusties that were there. By the way, while I'm doing this, I believe I said I know I said in the initial video that I thought these were a peculiar form of electrolytic capacitor and that I might have to replace them. The truth of the matter is, those appear to be film capacitors, so they don't leak, which means I'm not sure where the green crusties came from on these transistors, as there are no electrolytics or batteries or anything else that leaks on these little spot generator boards. Okay, so the vinegar took off the corrosion. The alcohol displaced the vinegar and cleaned the boards up afterwards. I guess we need to leave those a few minutes to dry before we replace the final two capacitors, and then we'll move on with further cleaning. I'm hoping we make it to the point where we can give the board some electrons and see what happens. We'll be back. Okay, we're back. Let's get these last two capacitors changed out. These two do not have markings on the board for their, they have the markings on the top for their negative side, not on the bottom like the main board. And those match the capacitors that are in there, so I'm going to trust it. Let's go ahead and pull these. Okay. And these have all been very easy to do because all of these boards are single-sided with no through-hole plating in the vias. So you really just have to get the solder off the top surface or the bottom surface of the board, and they come right out. Okay. Now, this one to this side is a 25 volt 10 microfarad. So I'm going to be replacing that with a 50 volt 10 microfarad. And it is okay to replace with a higher voltage as long as the capacitance value matches. So the negative goes to this side. And this one is a 25 volt 100 microfarad. And this is also a 25 volt 100 microfarad. In this case, the negative goes to the bottom. And that's where we've got it. And that's the last of the capacitors replaced. Now, the daughter boards have all been cleaned, looked at them, and I'm not seeing too much of the green crusty remaining behind. So we've got most of that taken care of. I didn't expect to get all of it, but we got a lot of it. Now, it is time to clean the card slots, and I'm going to do that. I'm going to use Deoxit D100 and this brush to get in there and try to polish the contacts some. And finally, I'm going to try to clean the potentiometers, and for that I'm using not D100, I'm using Deoxit F100L Fader Lube. And to make my life easier, I'm going to put a little mark on each of these, indicating where the top is currently, so I can get them set back where they are right now. Now to see if we can get some of this into each of these potentiometers and get them cleaned up. Okay. I think that's all the cleaning we're going to do. So, it's time to see about putting the daughter boards back in. Wall spot generator. W. These go in with the finger side facing to my right. So, wall spot generator. Still a tough fit, but that means it should be making good contact. Summer is this one. Horizontal sync generator. Ball spot generator. There we go. Layer 2 spot generator. This is the vertical sync generator. Ball flip-flop. These two are flip-flops, and I think they're identical. I didn't mark a B on one of them, so I'm going to assume they're identical. Gate matrix is this one. English flip-flop. Oh, And this is player 1 spot generator, yes. So, all the cards are now back. We're left with trying to throw some electrons at this thing to see if it works. Now, we're going to have a problem in that I can't use this cable to hook to a television because it's got the incorrect end on it. I could modify this cable, and I may do that. Put an RCA jack on it. Or we can try to get composite video. If you look at this schematic, you'll see that the composite signal comes out of summer on pin 10. It goes to the modulator. This is composite signal, composite video. Goes up here, across, and up into FB1. FB1 is this ferrite bead on the right hand side here. So I can theoretically get composite video off of that ferrite bead, or we can get it off pin 10 on summer, which is this pin right here, which just jumps across to the ferrite bead, so that's the right place. I'm going to see if I can take it off of the ferrite bead. I think I'm going to have to remove the horizontal sync generator to get at it. Okay, hooked on there. Hook this other lead up to a good ground. And as it happens, a good ground is the RF can. So I'm going to grab the RF can for ground. We're going to find out if we can see a video signal on the oscilloscope. Okay, I fluxed up. Quelle surprise. I recorded a bunch of video testing this board out, and I toggled the wrong toggle on OBS and failed to record the oscilloscope. So, I threw electrons at the board, and I connected up the oscilloscope to the output of summer, which should be a composite video signal. And what I got looked a little okay. What I was seeing was the horizontal and vertical sync. Now, their timing was off a little bit, so I had to adjust the potentiometers for that. But I did get them very, very close to 60 hertz and 15.75 kilohertz. So the vertical and horizontal sync were looking pretty good at that point. But I wasn't seeing the player spots, the ball spot, or the wall spot. And I figured out that one, you have to have the controllers attached or you're not going to get much of anything. So I've attached the controllers now. This is player 1, this is player 2. When I did that, I started getting the player spots and the wall spot. The ball spot is still not, I can't tell if I'm seeing it in the oscilloscope trace. It may just not be sampling at the right time. But I did do a little scoping and found that the wall spot generator, it's supposed to be generating a voltage between 0 and 2 volts on the ball spot generator. However, it's only generating a little over 1 volt. So there's something going on with the wall spot generator, or the ball spot generator rather, that we'll have to look into. But what I did get, and I'll show you on the oscilloscope now that it's actually recording, which we're still hooked up. I have the bench power supply set up to supply 9 volts DC, and over voltage and overcurrent protection are both on, and we're going to limit it to 500 milliamps. This board, however, uses virtually nothing. When I had it running, it was running at about 15 milliamps, so shouldn't have any problem there. Nothing blew up when I powered it up, so that was good. So if I power it up now, you'll see on this oscilloscope that we have composite video signal, and you'll notice that there are 3 spikes. The center spike is the wall, and you can see that by if I adjust the wall centering potentiometer, it moves. The left spot is player 1. I can move it horizontally, and it moves in the board, or in the composite signal. And the right hand spike is player 2 paddle. So you can see those. And I'm not seeing a 4th spike for the ball, and that's what I need to look into. The other thing you'll notice about the composite signal, other things you'll notice about the composite signal, the vertical sync, which is the ones you see flashing, the vertical sync appears to be a little higher than it should be. It should be down around the same level as the horizontal sync tip. Second thing you'll notice is that there is a significant DC offset here. We are running around 600 to 650, looks like, millivolts as the Vmin, and those should be down around 0. So there is a significant DC offset. Now, I did play with that a little bit and try to use a capacitor to decouple the DC, but I didn't have any luck with that, so I'm not sure how I'm going to have to go about fixing that. I think I'm going to have to rely on people much smarter than myself to help me out with that. Now, also, I have seen Mark from the Retro Channel's latest video on his Atari Video Music and how he got composite video out of that. So I did attempt to use a 2N2222 transistor as a buffer. Mixed results. The signal, it was traveling such a large distance between the components on the circuit board and the little buffer circuit I made on a breadboard through these wires that I was getting a lot of interference. So it was hard to work with. I may have to go, if I want to get composite out, I may have to go closer to the actual circuit board to build that in. But I'm going to start relying on you guys at this point to give me an idea of where I need to go, what I need to do here. You guys, the community is so generous always with helping out, and I would greatly appreciate any help you can offer me. And I'm also probably going to go ahead and see if I can reach out to Mark. Mark has a Discord channel where you can get in touch with him, and he does offer assistance. So I'm going to put together a message to him and ask what he would recommend that I do. I'm no expert on analog circuitry, and certainly not on composite video signaling. Mark, he's made his RF off Commodore 64 modulators. They're wonderful devices. He's studied these things in great detail, studied composite video in great detail. And I expect he will have some wise and sage information for me, and I also would imagine some of you in the community have wise and sage information for me that you can put in the comments below. Also, if you want to reach me, I have a Discord. So if you want to connect with me there, that's a good way to do that. My Discord will be linked in the comments below. So I think that's about as far as I can take this today. Once I get a good composite video signal out, and I did try connecting this, with and without the capacitor, with and without the buffer. I did try connecting this to the RetroTink, and it was never able to lock onto a signal. Oh, another thing you'll notice about the composite signal that you're seeing on the scope is that it's missing a couple of typical characteristics of a composite video signal, but those shouldn't be a problem. Those are the back porch, which it doesn't need because it's black and white signal, so it has no color burst to put in the back porch, or put in between the back porch and the front porch. And it has no a normal color video signal would have both a base level and a black level. So there'd be a step between the horizontal sync pulse and the start of the luminance signals. Again, I don't think that's a problem because, again, this is a black and white signal, and this basic signal should be enough. One more thing I can do, and not set up to do that right now, is that I do have the PVM, black and white PVM monitor that I was using with the Apple II Plus. I can try to hook up composite video to that and see if that works any better than the RetroTink does. But one way or another, we need to get a composite video signal out so I can see if we're getting anything from the ball, and then I'll try to analyze why the ball is not giving us a good voltage level. That being said, I think that's going to end this video. So you've seen it powered. It's working in many ways, not every way, but it's at least giving us something, and it didn't blow up. So that leaves me to say, if you want to support the channel, there are 3 ways to do that. Patreon, joining the YouTube channel membership via the button below the video, or Ko-Fi. You can buy me a coffee. The link for Patreon will be in my description. Please, if you enjoyed this, and I know we didn't get to as much electronics as I'd hoped to, or actually we did, but I didn't record it because I was an idiot. But if you did enjoy the video, I'd appreciate a thumbs up. If you didn't, you know what to do there too. And leave me a comment. I appreciate all comments. I appreciate interacting with you folks. So please hit up the comment section below, especially if you're going to put a dislike on the video. Leave me a comment and let me know why. I am always looking to improve. I know I'm not perfect. I know I'm not great at this. I'm always looking to improve and do better for you guys. So, likes, comments, support. Share the video to anyone that you think might enjoy it. Particularly if you happen to know anybody who's good with composite video signals, share it to them so that maybe I can get some more help. And thank you for all the help you do give me, whatever it may be. I very much appreciate it. And that, I think, will do it. So thank you for watching. Until next time, everybody be healthy, be safe, all that good stuff. And we'll see you.